Okay, welcome everyone. Radical expression 2 square root of 5 plus 4 square root of 5. A radical expression means if an expression has radical sign in it, we call it radical expression. So radical expression, we add the like terms. Again, like if there is an 2x plus 3x equal 5x. The same idea goes for the radical expressions. So 2 square root of 5 plus 4 square root of 5. In the total we have 6 square root of 5. As you know, square root of 5 is an irrational number. Of course, 6 times square root of 5 is an irrational number too. There are some properties. Square root of a number multiplies itself. It's equal to the number itself. So what does it mean? Square root of 3 multiplied by square root of 3, it's equal to 3. Or square root of 2 multiplied by square root of 2, it's equal to 2. That's the first. Negative of them is same. Now they say it's not negative inside the square root, but negative square root of 5 multiplied by negative square root of 5. Negative times negative is positive. Square root of 5 multiplied by square root of 5, it's going to be 5 again. So be careful here. It's negative times negative positive. Because of that, the result must be positive. Multiplying square root, if we have a number inside the square root, let's say 9 times 5, that's gonna be square root of 9 multiplied by square root of 5. And square root of 9 is 3 square root of 5. As you see, that's how to simplify the square root. That's a good property of a square radical of square root. Divided by square root, here be careful, a and b must be bigger than 0. b cannot be 0. We cannot divide by 0. These are given because of that, and inside the square root cannot be negative, don't forget it. Such as what? Let's say square root of 20 over 5, it's exactly equal to square root of 20 over 5, square root of 5. Or let's say square root of 8 over square root of 2, this is equal to square root of 8 over 2, square root of 4, that's gonna be 2. So we will use these properties to simplify, there's no equation, sorry, square root expressions. These properties are important. So let's see another properties. I think there is no left. 1, 2, 3, and that's okay, 3 of them. Let's now evaluate. So we need to find the values. Square root of 36, 6 times 6. So how do we evaluate it? I will write the long process 1 times. 36 is 6 squared, and if we know square root mean 6 power of 2 power of 1 over 2, that's the square root idea, and in the powers we multiply them. 2 times 1 over 2, 2 times 1 over 2 is 1, 6 power of 1 equals 6. We are not writing that one. Instead of writing all these steps, we are cancelling 2 and square root, and it's equal 6. Such as in the second example I'm gonna do, that's called negative square root of 8 squared is 64. 2 power of 2 and root cancel each other, that is equal negative 8. Let's see another example. Here square root of 3, here square root of 3. They are like square roots, so like terms we can call 8 minus 6. What is the idea behind it? I can factorize the square root of 3, so 8 minus 6. 8 minus 6 is 2 times square root of 3. Instead of writing that one, 8 square root of 3 minus 6 square root of 3, 2 square root of 3. Let's see, 9 plus 4, so 9 plus 4. And this one, sorry, don't confuse about how I circle it, because don't forget, signs are belong to their terms. That's a plus 9, that's a plus 4. So 9 plus 4. That's a plus 3 square root of 7. Plus 3 square root of 7. And this is minus 5 square root of 7. So 9 plus 4 is 13. 3 minus 5, I can do that one. 3 minus 5 is minus 2 square root of 7. So 14 minus 2 square root of 7. Okay. What is the idea of that one? That's a property. I can write square root of 4 over square root of 9, and that's equal 2 over 3. Why? Square root of 9 is equal 3. Okay, let's continue. That's 0.04. That's an interesting number. I can write it as a fraction. How? Negative 4 over 100. Because of the property, I can directly write square root of 4 is 2, and negative, don't forget this value is negative. Square root of 100 is 10. Instead of writing these steps, you can mentally do that one. Square root of 4 is 2, square root of 100 is 10, because the property let us do that one. Negative 2 over 10, is it enough? Of course, we can simplify 2 over 10, negative 1 over 5. Don't forget to simplify the fraction. Simplify each radical by factorizing. That's an interesting value. Square root of 49, it's equal 7. It's equal 13. Why 13 times 13? 576. That's an interesting one. I don't know exactly the value, so how can I do that one? I can try 23. Because I know 3 times 3. No, 23 is not possible because 3 times 3 is 9. So I can try 24. Why? 4 times 4, 16. 4 times 4, 16. 1 is here. 4 times 2, 8. Plus 1, 9. 2 times 4, 8. 2 times 2, 4. Add them. 6, 7. 1 is here. 576. So 24 multiplied by 24, 576. So the square root of 576 must be 24. That's a good value. How I can solve that one? I can make it 36 multiplied by 100 and 36 multiplied by 100. I can separate because of the square root value. 6 times 10. Square root of 36 is 6. Square root of 100 is 10. 6 times 10, 60. You can do these steps mentally, or you can directly say 60 multiplied by 60. 192. I don't think it's a perfect square. I know 196 is. 192. Is it divisible by 4? Yes. Let's try. 192 divided by 4. 4 times 4, 16. 3 and 2. Let's say 2 times 42 and 30. No, not 8 times 48. It's equal 4 times 48. That's not enough. 48 equals 16 times 3. So 4 times 16 times 3. 4 times 16 is 64. So square root of 64 multiplied by square root of 3. Square root of 64 is 8. Square root of 3. That's how we simplify this expression. Simplify each expression again. As you can see, if you pay a little attention, 3 times 12 is 36. So you can use property to write 3 times 12 inside this radical sign. So square root of 36 is 6. 8 times 18, I'm not sure about that one. And I can simplify that both difference method. I can use 2 difference method. How? I can try 8 times 18. 8 times 8 times 8, 64. 8 times 1, 8 plus another 6 because of the 64. It's gonna be 144. So square root of 144. I can do that one because I know square root of 144 is 12. So I can use 8 times 18, 144, and it's equal 12. This is one method, so we can try that one. Can we use another method? That's an interesting question, and that's my main point here. Square root of 8, I can use square root of 2 multiplied by square root of 8. For 18, I can use square root of 9 and square root of 2. Square root of 8 is square root of 4. So 4 times 2, 8. 9 times 2, 18. This is gonna be 2 square root of 2. Square root of 4 is 2. Multiplied by 3 square root of 2. 3 times 6. Square root of 2 multiplied by square root of 2. 2. It's gonna be again 12. That's another method. I couldn't write clearly. I am sorry. Let's write everything again clearly for these steps. What I did, of course, 18 times 8 is works and 144. If you don't realize it, it's a perfect square number. You can solve it that method. 4 times 2 is 8. Multiplied by 9 times 2 is 18. Square root of 4 is 2 square root of 2. Multiplied by square root of 9, 3 square root of 2. What we know? 2 times 3 is 6. Square root of 2 multiplied by square root of 2. It's gonna be 2. 6 times 2, 12. This is another method. Of course, square root of 8 multiplied by 18, it's equals square root of 144. then this is equal to 12. That's more easier. Yeah. 48 times 3. 3 times 8, 24. 3 times 4, 12, plus 2, 144. So square root of 144, it's equal to 12 again. 54 times 6. 6 times 4. What is it? 24, yeah. 24. 2 is in my mind. 6 times 5, 324. I'm not sure about what kind of perfect square is that one. So I will use the other method. What is it? 54, it's equal 9 times 6. So 9 square root of 6. Sorry. I will use the second method. Square root of 9 multiplied by square root of 6 multiplied by square root of 6. 9 is 3. Square root of 6 multiplied by square root of 6 is 6. 3 times 6, 18. So that's the end of that part. Let's solve a few more examples. As you see, division. 64 divided by 16 is 4. Square root of 4, it's equal to 96 divided by 2, it's equal 48. Yeah, that's square root of 48. To simplify that one, I can say 16 multiplied by 3. 16 multiplied by 3, 4 square root of 3. Don't forget 16. You can take out of square root of by 4. Square root of 50 divided by square root of 8. That's an interesting one. I can write it 50 over 8. Then simplify by 2. It's going to be changed 25 over 4. 25 over 4, it's equal 5 over 2. Can you use same method for the 150? You can divide by 100 by 50 by 6. It's going to be 25. So it works. 150 over 6, it's equal 25. It's equal 5. How? 150 divided by 6 is equal to 25. You use division. Okay, simplify each expression. Assume that all variables are non-negative, non-zero. So this means inside the radical they cannot be negative number. That's the idea. What we know, I can write that square root of a power of 4 multiplied by square root of a power of 6. And I told that square root of mean power of 1 over 2. A power of 1 over 2. B power of 6. 1 over 2. 2 times 1 over 2 multiplied by 4. 4 times 1 over 2 is 2. A squared. 6 times 1 over 2. B cubed. That's the first method. That's a method. That works. Let's clean everything here and use another method. I can use that one. A squared of square in the square root and b cubed of the square under the square root. Square and root cancel each other. Square and root cancel each other. A square multiplied b cubed. That's another method. Let's solve that one. X power of 4. So power of 2 under the square root. And y power of 9. Power of 9 I cannot write as a square. So only x power of 4. Square and root, let's cancel each other. And y power of 9 stay inside. That's another one. Same goes that one. That's gonna be 6 divided by 2. You can try that one when we have square root. So a power of 3, 10 divided by 2, b power of 5. So x power of 3, it's not divisible by 2. It's say x power of 3 over 6 is divisible by 2, y power of 3. That's another result. Let me check how many examples left. There are lots of examples. I'm not going to solve all the examples here. I will solve a few of them. That's so easy. 3 plus 4, 7 square root of 5. All of them 5. So you can add like terms. 4 plus 2, 7. So 4 plus 2, 6. Minus 5 is 1. 1 square root of 5 is square root of 5. Square root of 3 not like terms. 6 minus square root of 6 is going to be 0. 2 square root of 3 plus 6. Plus square root of 6 minus square root of 6. Let's save that one. Okay, let's continue. A few examples here. So that's will be the end of the video. Unit use distributive property. 4 times 1, 4. 4 times minus square root of 3 minus 4 square root of 2. Square root of 3 multiplied by 1 plus square root of 3 minus square root of 3 multiplied by square root of 2. That's gonna be 4 minus 4 square root of 2 plus square root of 3 minus square root of 6. They didn't cancel each other. Okay. I cannot simplify that one actually. That's an interesting one. Let's say 6 plus 3 square root of 2y, 9 times 2 over 3. And 6 over 3 plus 3 square root of 2 over 3, 2 plus square root of 2, that's the answer. Square root of 5, so I can do that one. Square root of 5 multiplied by square root of 2, no, sorry, 3. Plus square root of 5 square root of 2 over square root of 5, not 2, sorry, 5. As you see, all of them by 5. You can factorize here by 5. Square root of 5, square root of 3 plus square root of 2 over square root of 5. That cancel each other. So the answer is square root of 3 plus square root of 2. I think that's enough. You can do similar example for that one. Thanks for listening. Oh, wait. There's a square, so I want to solve that one. It is one of these one. Here's square root of 3, and what we know in I can write x plus y, x squared plus 2xy plus y squared. There was a rule. So what is x? Square root of 3 squared plus 2 times square root of 3 multiplied by 2 plus 2 squared. Square root of 3 is outside. It's gonna be 3 plus 2 square root of 6 plus 4. Square root of 3 plus 4 is 7. 2 square root of 6. 7 square root of 3 plus 6 square root of 2. The answer, when you multiply it 1 by 1, 3 times 6 is 18. Hey, that's 3, sorry. So it's going to be 2 square root of 3 times 6, square root of 3 multiplied by square root of 6. It's going to be square root of 18, and it's 9. So 7 square root of 3 plus 2 times 3 times square root of 2. It's going to be equal 7 square root of 3 plus 6 square root of 2. That's the last example for this video. Thanks for